What if the universe isn't an empty vacuum, but a rigid crystalline structure that is actively melting? Welcome to the Geometric Thaw. In the early universe, the cosmic web was deeply rigid. But as billions of stars ignite, their thermal exhaust physically melts this crystalline spacetime into a smooth, viscous fluid. This thermodynamic process creates a delayed reaction. First, the stars release intense heat. After a temporal lag, the rigid space-time web finally softens, stretching outward. This is the true origin of dark energy. It is not a mysterious new force, but the structural thawing of the vacuum. As the tension breaks, the universe accelerates into the void. At the galactic scale, this melted space-time behaves like a thick, viscoelastic fluid. As a galaxy spins, it drags the surrounding metric, creating a visible wake of warped geometry. Instead of invisible dark matter particles, this space-time fluid naturally thickens and becomes stickier at the galactic edges, physically holding the outer stars in fast, stable orbits.
When massive galaxy clusters collide, this sticky space-time fluid gets caught and peeled away. The warped geometry is left lagging behind the visible matter, perfectly matching weak lensing anomalies.
Because the vacuum is a thick fluid, it acts as a shock absorber. Fast ripples pass cleanly, but massive, slow-moving gravitational waves from black holes are heavily damped by its resistance. Zooming into the quantum realm, when heavy ions collide, they generate immense heat. The perfectly cold quantum vacuum lattice instantly melts into a bubbling, highly viscous liquid. As the hot plasma from the collision expands, it hits the cold vacuum boundary. A chaotic slash layer forms, instantly absorbing and muffling internal sound waves. In standard physics, missing collision energy is blamed on invisible particles. Here, it is consumed as latent heat to melt the background metric. It's a temporary energy sink in the fabric of reality. In future high-luminosity colliders, these melted vacuum bubbles will expand and merge. An interconnected thermodynamic lake of melted spacetime will form, proving the dynamic, superfluid nature of our universe.